Today we will learn about projectile motion. Projectile motion is that when a particle is thrown in the space which moves under the effect of gravity alone. So there is no any other thing, only gravity acts. And that is known as projectile motion, and we call that kind of motion as projectile motion. For example, an arrow released from a bow and also a bomb released from an aeroplane. This is an example of constant acceleration. That means if you give constant acceleration to a particle in oblique direction with initial velocity, see this is oblique direction, right? With initial velocity u, then you are getting the path as parabolic. See, this is a parabolic path. Now let's consider the components. Here we have the horizontal component as ux is equal to u cos theta and ui is equal to u sin theta. And you can see when it reaches over here, we are having a vertical component that is known as Vy, and we could write this as u sine theta minus gt. This is the same equation as u plus at. Now, when it reaches this point, the final velocity is 0. That means the vertical component of velocity is equal to 0. The horizontal component is u cos theta. Look, here also the horizontal component is u cos theta. You could see an angle alpha here. Did you see? Yes. So how will you find tan alpha? That is the direction. Tan alpha is always perpendicular direction to the base, right? So we have perpendicular component as u sine theta minus gt divided by u cos theta. That means Vy divided by Vx. So we got two components, tan alpha as u sine theta minus gt by u cos theta. And now let's take the horizontal components as ux as u cos theta and vertical component uy as u sine theta. Hope the diagram is clear, right? Now we are having projectile motion. We can consider projectile motion as two. That means it is having horizontal motion plus vertical motion. This is vertical. Okay. Okay, right. So in horizontal motion, as you consider ux is u cos theta from the previous diagram. What is the corresponding acceleration there? That means the x component of acceleration that is equal to 0. How? We are neglecting air resistance also. Now we can say that horizontal velocity remains unchanged here. That means it always be same. So at any instant of time, whenever you take it at 1 second, 2 second, 3 second, at what time horizontal component of velocity remains u cos theta. And you could say at any time t, x coordinate or displacement along x direction is what? X is equal to velocity into time, right? So it is x is equal to ux into time. So x can be written as u cos theta multiplied by time. Now consider vertical motion. What is vertical motion? This is happening under the effect of gravity alone. That means particle is moving upward. It has vertical speed of minus g because vertical speed and the acceleration component is negative g. That means ay is negative g. And if you consider vertical speed at time t, you are getting vy is equal to uy minus gt. Now let's consider the displacement right now. You can substitute uy. That means you are getting uy as u sine theta. You take t and minus half gt square. Somehow the height is of the particle above the ground is given by the equation y is equal to u sine theta minus half gt square. This is the expression for the displacement in vertical direction in time t. So check this diagram again. You will find things right now. Ux is equal to u cos theta, uy is equal to u sine theta, vy, vx, all things. Hope it is clear. Now, what is net motion? Always the initial velocity is horizontal component uxi plus vertical component uyj. So we write u cos theta I plus u sin theta j. And what is net acceleration? It is axi plus ayj. We know that horizontal component of acceleration is 0. So only a remains as minus gj. Hope that is clear. Now let's take the coordinate of particle at time t. Let's take x is equal to uxt. And what is y? That is uyt minus half gt square. We got that one. Now, if you want to get the displacement, you take x square plus y square, take the root. Now, if you consider the velocity of particle at time t, we write v is equal to vxi plus vyj. What is v? Uxi plus what is g? Vy? It is uy minus g tan c y direction. I'm not writing u sine theta right now because just to represent the component. But you can change it as u cos theta I plus u sine theta minus gt into j. Now let's take magnitude of velocity is vx square plus vy square. As you know that we have taken the tan alpha. What is the tan alpha? Yeah, it is Vy by Vx. So we can write u sine theta minus gt divided by u cos theta. Hope that makes sense. Now let's consider the time of flight. As you know, time we take it as t. That means from here to here it reaches here, right? So this is the departure time, this is the arrival time. Okay, we take time t. So what is the displacement along y-axis? Is there any displacement? No, we consider it as 0. So we put 0 is equal to u sine theta t minus half g t square. Take this to here, you are getting t is equal, that means half gt square. Dt square is equal to u sine theta t. Cancel this t. So what are you getting? Take this 2 here. So what are you getting? T is equal to 2 u sine theta by g. Clear, children? Okay. So actually u sine theta is what? The vertical component of initial velocity, right? So you can just write like that. Now, if you take the ascending time and descending time as t by 2, you just divide the equation by 2. You are getting u sine theta by g. So, that means at time t by 2, that means half of the time, particle attains maximum height of its trajectory. Very important point. Now, let's take horizontal range. During its complete flight, what is the displacement of the particle along x direction? So x you can write, x only we are taking. That means horizontal range. Okay. U cos theta multiplied by t. You already got what is the value for t. You multiply u cos theta. You'll be getting r is equal to u cos theta by into t. You take u square. You write u square. Cos theta sin theta. This one by g. And you know that what is 2 sin theta cos theta. What do you remember? It is sin 2 theta. So it is range is equal to u square sine 2 theta by g. And what is actually this sine theta is ux and u sine theta and u cos theta. So you can also write like this. So what you are getting range? This one is a ranges equation. Now you put what is maximum height. You know that maximum height vertical velocity become 0, right? This will become 0. So what will that means at this instant y coordinate is its maximum height. You take vy square is equal to uy square minus 2gy. What is this equation? Do you remember? Yeah, this equation. Same equation. Instead of a, what do we write? Minus g, right? So we put 0 uy square minus 2gh. What are you getting for h? U square, that means uy square divided by 2g. So you're getting maximum height as u square sine square theta by 2g. So for getting horizontal range, we have to take x. For vertical height, we have to take y. Okay? For this horizontal range, you are getting maximum, that you are multiplying this with t. So this t is you are getting from time of flight. Vertical high, you take it as 0 and also you use v square u square plus 2a as equation. But here a is negative g. Only that is the difference. Now the equation of trajectory. We have written that x is equal to u cos theta into t. Y is equal to u sin theta t minus half gt square. Now on eliminating t from these two equations. Okay, instead of t, I write x by u cos theta. From where you are getting that one? X is equal to u cos theta t. Okay, from this one, I am writing t is equal to x by u cos theta. Got it? Okay, here also, right? So x tan sine theta by cos theta is tan theta minus half g x square by u square cos square theta. Okay, and you know this is the equation of the parabola. Always equation of parabola looks like this: ax minus bx square. So you can take this as there is an x here, there's an x square here. Okay, now what is the energy of the projectile? When a projectile moves upward, what happens? Kinetic energy decreases. And potential energy, what happens? It increases. But the total energy remains constant. What do you mean by this? This is energy conservation. So what is kinetic energy? Half m u cos theta. You put x v square instead of v square, you put cos theta square minus half m u square cos square theta. Why not sine theta? Because we are considering kinetic energy. If you consider potential energy, you have to consider this height. So instead of height, we have this equation, right? We substitute this equation and we are getting half m u square sine square theta g cancel. So what is kinetic energy plus potential energy? You are getting half mu square cos square theta plus half mu square sine square theta. Take cos mu square outside, cos square theta plus sine square theta is 1. So this is energy at the point of projection and this is in accordance with law of conservation of energy. Also, we can find out the velocity as we put half mu square is equal to half mv square plus mgh. This is the total energy, right? This is the kinetic, this is the potential energy. You cancel m and we are getting v as under root u square minus 2gh. How? All m cancelled. Okay, u square by 2 will be there. V square by 2 plus gh. This will be the equation, right? Or you have to take the LCM, multiply by 2. So what happens? u square, v square plus gh. You have to multiply this with 2, right? 2gs. And you take the 2 common. All 2 cancel. Okay? Common means 2 cancel. So what is v? U square minus 2gh. I mean v square. Take under root. So v is equal to u square minus 2gh. Okay. Is that clear right now? These are all things for projectile motion.